Now next one, another examples about marginal probability function, marginal probability and joint probability. So let's try with another real life example. So if we flip two unbiased coin and one unbiased die simultaneously, then what is the sample space? So we know when we flip two unbiased coins, then there will be there. So if we consider just two unbiased coins simultaneously, then we know there will be four outcomes: HH, HT, TH, DT, right? But if we consider it with another one unbiased die, then this is the sample space. That means HH1, HH2, HH3, HH4, HH5, HH6. So this way we will have 24 sample elements, right? Now, if we define our random variables, x is number of heads and another random variable y is dots are even. That means for die, we only consider the even number for y. That means this one, 2, 4, and 6. So how we get the marginal total? We know g of x equals to summation of p of xy. Summation is over y when we want to get the marginal total for x. Similarly, when we want to get the marginal total for y, then we will have the summation over x on their joint probability function p of xy. So this table shows the probability value of their joint probability as well as their marginal probability. Again, for example, if x equals to 0 and y equals to 0, that means the joint probability of x equals to 0, comma y equals to 0 is 3 by 24. So this way, these probabilities are, we can consider them as joint probability. What about their marginal probability? Say when x equals to 0, then the marginal probability is 6 over 24. When y equals to 4, then the marginal probability is 4 over 24. So these tables, it contains all joint probabilities of x and y and also the marginal probability of all the values of x, for example 0, 1 and 2, and all the values of y, 0, 2, 4 and 6. Okay, so now another example for joint probability function. So again, if we consider x and y two random variables where x equals to 0, 1 and 2 and y equals to 0, 1, 2, 3. So these are the probability values, right? And we already know that these are the joint probability values. So when x equals to 1 and y equals to 1, then the joint probability value is 1 by 12. And also about their marginal probability, if x equals to 0, then the marginal probability is 4 by 12. If y equals to 3, then the marginal probability is 3 over 12. Now our task is to calculate probability of x is greater than 1, probability of 0 less than y less than 3. So that means first of all we need to calculate their marginal probability function from the joint probability function, and then we can find out the value of probability of x greater than 1. So let's see how we can solve it. So see, for example, probability of x is greater than equals to 1. That means probability of x equals to 2 only, because x can take 0, 1 and 2. So x greater than 1 means only we have x equals to 2, and this marginal probability value is given in the table. So this is 4 over 12, that means 1 over 3. Similarly, if we consider probability of y lies between 0 to 3, then we have seen that the value for y is 0, 1, 2 and 3. So between 0 to 3, there are only two values, probability of y equals to 1 and probability of y equals to 2. So just we are taking this summation and we will have the probability value half for the value of y lies between 0 to 3. Now our next question is we have to find out expected value of twice x minus y. So from our previous chapter, we know that we can write it in this way: 2 times expected value of x minus expected value of y. So first of all, we need to calculate expected value of x. So expected value of x equals to summation of x, y over x over y times x. That means, so 0, when x equals to 0, the marginal probability is 4 over 12. When x equals to 1, marginal probability is 4 over 12. When x equals to 2, the marginal probability is 4 over 12. So this way we will have the value for expected value of x is 1. Similarly, we can calculate the value for y. Expected value of y is 3 over 2. So finally, the value for expected value of twice x minus y is half. Similarly, we can also calculate variance of x minus twice y. So for this form, we can write variance of x plus variance of y plus 2 times covariance of xy. But here covariance is 0. Why? Because x and y are independent. So we have already known that how to calculate variance of x and variance of y. So we can calculate variance of x by using expected value of x square minus expected value of x whole square. So we know expected value of x square equals to summation of x square g of x. So now what about g of x? G of x is the marginal probability of x. So we know when x equals to 0, it is 4 over 12. When x equals to 1, it is 4 over 12, and x equals to 2, it is 4 over 12. So we can calculate expected value of x square by using this formula, summation of x square g of x, and the value is 20 over 12. So our variance for x is 20 over 12 minus 1, so it is 8 over 12. And similarly, we can calculate the variance of y as expected value of y square minus expected value of y whole square. So expected value of y square equals to summation of y square h of y. That means we need to square all the values of y, then taking their product with their corresponding marginal probability, and the value is 42 over 12. So variance of y is finally 15 over 12. So our final task is to find out the variance of x minus twice y. So that means we can write variance of x plus 2 square into variance of y. So it is 68 over 12.